Hello everyone, this is Felix from GMWolf. Today we're going to be looking at how we can make this really nice grass animation you can see playing on screen here. This tutorial we're going to be looking at how to use Vertex Buffers and how we can modify the Vertex shader in order to animate our Vertex data. So before we jump right into the code, let's first have a look at how this will actually work. So essentially each of our blade of grass is made out of a number of triangles, and then the triangles can be modified, it can be animated inside our Vertex data. So there isn't any sprites or any texture or anything involved, it's just all done with vertices. So without any further ado, let's get to coding. Alright, so we're going to start off by creating a quick sprite which will represent the patches of grass we're going to place in our room. So for this I'm going to make a very simple rectangle with an alpha, with a lower opacity center like so. I'm going to call it S grass like so. And to go with it we're going to be creating our object, which is going to be where all of our code is going to reside. So we're going to call this O grass. And what the point of this object will be is inside a room you'll be able to place it and stretch it out to be able to have as long a patch of grass you want. The advantage of stretching out your object like so instead of creating lots of different objects is that it'll be more efficient by keeping everything in a single draw core, in a single model. So this is going to be our test object for now, test instance in our room, so we won't ever need the room again, and now we can start creating our code. So let's add a create event and make it go full screen. This is where we'll create the vertex geometry, vertex data for our grass objects. So what we're going to be doing first is find out the size of our object. Now luckily there are built-in variables for this, which are sprite width and sprite height. So what these do is actually take the size of your object, the size of your actual sprite, sorry, and the image X scale and Y scale in order to determine the actual size of your object in the room. Now for all the code we could use sprite width and sprite height, however just having a width and height makes it a bit clearer. Next we need to decide on the size of each of the grass blades and the separation between each of them. So the first variable we're going to have is blade size, and for this example we're going to set it to 48. And then we have a blade separation, which we have to set to something a bit lower so the grass looks a bit more natural. And you can go with something such as 40, maybe a bit lower like 38 or something like that. So in order to use a Vertex Buffer, we need to decide on the format, and what that means is what data our buffer is going to hold. So what data is going to be in each of the points. And for that we create a Vertex Format like so by using Vertex Format begin. This tells GameMaker we started defining a new format. So our format will actually have a position like so, so that's a two-dimensional position, and a color, Vertex Format add color like so. Now we need to tell GameMaker that we're done defining our Vertex Format and we would like to have a reference to it, and this is done by calling vertex underscore format underscore end, and the return value from that will be a reference to our Vertex Format, which we can store in a variable. Here we're using format. So now we can actually start to write our, create our Vertex Buffer, which is where all our data is going to be stored, where all the actual geometry is for our grass. vbuff is equal to vertex underscore create underscore buffer. Now what this does is it allocates memory that's ready to be used by GameMaker in order to add all your vertex data in there, and it gives you back a reference to that place, to that buffer, such that you can add data to it and you can use it later on. Now we want to tell GameMaker that we're ready to actually populate the vertex buffer with some data. So we're going to use vertex begin, is it? Vertex begin, yes, and we're using our vertex buffer that we called vbuff earlier on, and the format we want to use is obviously the format we created earlier. So now what we want to do is go all the way from the start of our object so from the left hand side all the way to the right hand side and add blades of grass all along. So what we can do is use a for loop which will start at 0. We want to go all the way to the width of our object, and we're going to increment it by our blade separation. So in here is where we're actually going to add our vertex data. So here's where we're going to be creating grass blades. Now before we forget, at the end of defining our vertex data, we need to actually call vertex underscore end to tell GameMaker we're done defining our data, we're done adding data into our vertex buffer, and that it's ready to be used. So you have to remember to call vertex end right at the end. So now we are ready to actually create the code that will add blades of grass. However, it is quite a large piece of code, and we're going to expand upon it later. And so what we're going to be doing is creating a new script, which we're going to be calling Vertex Blade. So what it will do is add some data, add vertex data, which is going to be like in the shape of a blade. So here you go, adds vertex data to the grass buffer, and the parameters it will take are the buffer we want to add to, the X position of our grass blade, the Y position of our blade. We also want the width of our blade. The height of our blade is also needed, and finally the number of segments our blade is split into. So the higher the number of segments, the higher the quality of your grass, but it may also be lower. A good number is between 3 and 4. I think 4 is quite a nice sweet spot to be at. Any more, you really can't see the difference. So now we can actually get all of these parameters into variables. So now that we have that set up, we can actually start doing some proper coding. So what we want to find out is the height of each of our segments, and that's actually quite simple. So we're going to create a new variable called segHeight for segment height, and it's just simply the height divided by the segment number. So each of our segments will be of height segHeight. Now we can actually start creating each segment. So we're going to create a simple for loop and loop through each of our segments. So we're going to start with I is 0. We're going to go all the way up to the number of segments we have and increase by 1 every time. First, we want to find out the width of the base of our segments. So each of our segments is essentially a little trapezoid, and what we need to know is the width of the base and the width of the top bit. So we can write base width, or base W, is equal to lerp width 0 I over segments. So here what we're doing, by lerping between width and 0 by I over segments, we're essentially creating a triangle shape as we go towards the top. Now you could use something else than lerp. You could use smooth lerp or something like that if you have better functions available. Here we're just going to be using lerp to make a nice triangle blades. However, depending on your game, depending on your art style, you may want to change this on how you prefer. The important part is that at the base it has to be width, and at the top it has to go all the way up to 0 in order to get that nice pointy edge. But again, you could use any interpolation function as long as they're nice and smooth. So now we want to know the top top width, and that's going to be again the same, 0, and instead of I over segments, we're going to do I plus 1 over segments, and this is essentially going to get us the base of the next segment, of the segment above. And what we want to do is have the top of our segment to match the base of the segment above, so it looks like it's one continuous blade of grass. What we want to do now is actually get the coordinates of each of the corners of our segments, and we're going to call these x1 for first of all the x coordinates of our first corner, and that's going to be our x position. To that we're going to be adding the width, and we're going to subtract the base width and divide by 2. So this is our first corner. Next we're going to have the y position of that corner as well, and this is simply yy minus I times segment height. Next we want to get our second corner, which is simply our first corner. So for the x coordinate, it's simply our first corner plus the width of our base. And the y coordinate is the same as our first corner, since it's supposed to be flat on the bottom. We can do the third corner now, which is our top left corner. So this is going to be very similar to before. It's just going to be xx plus the width minus the top width over 2. And our y on the y-axis, it will be our will be the same as our first coordinate y point minus the segment height. Finally, we have our last corner, which is the top right corner. This is going to be, again, very similar. We take our third corner, add the top width to it. And for the y coordinate, it is the same as our third point. So now we have the 4 corners of our trapezoid, of our segments. So we can actually start creating different triangles. So let's start with the first triangle out of 2, and we're going to need to add our vertex data, and we can use vertex underscore position to first of all add a position. We want to add it to our vertex buffer at position x1, y1 for the first corner, and then we have the color. So we're going to use vertex underscore color vbuff. And for now, we're going to be using C underscore green and an alpha of 1. Now, it's important to realize that for each of our vertices, for each of the points on our segments, on our triangles, we are using we're using the data in the same order that we defined it in the create event. So here in the vertex format, we first said position, then color. So it's important that inside our definitions here we go position and then color. So now we can go on the second coordinate, the second point of our triangle. And so it's very much the same story. Position, we're adding to our same vertex buffer. We are adding the point x2, y2. And for now, the vertex color we're just going to leave again to green with an alpha of 1. We can now do the third point, which is again being added to our buffer. We are using the third point x3 and y3 and adding a vertex color again. We're using green with an alpha of 1.0. So here is our first triangle of our trapezoid. So we're going from the bottom left corner, which is this here, to the bottom right corner and the top left corner. Now what's important to realize is that we are defining all of our triangles in counterclockwise order. if we go clockwise and we enable culling, then we won't be able to see our triangles anymore. So it's important to use the same order when defining your triangles. So now we can go ahead and do our second triangle and last triangle. Here we're going to be using the second, fourth and third points in this order. So very actually what we can do is simply copy our first triangle, paste it down, and we can again use the second here. Next we go to the fourth one, and finally we can use the third one as it is. And again, this ensures that we're doing it in the counterclockwise order to make sure that our triangles will show. So this is it right now for our Vertex Blade script. So we can save this and go back to the create event. And here we can actually call the script we created. So we write Vertex _ Blade. The Vertex Buffer is the one we already created, vbuff. The position is going to be x plus I. So remember, I is not a simple index, it's actually the number of pixels from the start of our object. Next, we're going to have y plus height. So this ensures that our grass blades start at the bottom of our object, not from the top of it. Next, we have the blade size, which is our width, the height of our blades, and finally the number of segments. 4 will do. So now we have created our very simple grass mesh, and we can start drawing it. So let's go back to our workspace, add an event to our object. We're going to use the draw one, and let's put this in full screen as well. So this is where we're actually going to be drawing the grass. Now this is pretty simple. We have a buffer. We can just do vertex submit our vertex buffer. Now we need to choose a primitive type. Now we used a list of triangles, so we can use pr_triangle list. And finally the texture. Now we're not going to be using a texture, we're just using the vertex colors, so we can leave it to -1. If we now save and run, we should be able to see a very simple mesh of our grass. And here it is. So we have a very simple mesh. It's not animated yet, it doesn't look very good. However, this is what we're going to be tackling now. We're going to be starting off by adding some nicer colors to our grass to make sure that it's a bit darker at the bottom, a bit lighter on top, and perhaps a bit more yellow on top, just to give it a nice effect. So we go back to Vertex Blade script, and we can start deciding on the different alphas and so on. So we're going to have a couple values to change. So first of all, we're going to change the alpha. So it's going to be different at the base from at the top. So we're going to have a base alpha, and this is going to be lerping between 0.9 and 0.4. These are two values I found work pretty well. And we're going to lerp by I over segments like before. We are also going to have a different hue to our sprite. So base hue is going to be at the bottom, and we're going to lerp, and values that work well with 115 and 40. So 115 is a bit of a bluish green color, and 40 is a bit of a more a yellowy green color. So it'll give a nice, as if it was denser at the bottom, as if there was more light being stopped by the actual blades of grass. It gives it a nicer color. And again, we're lerping by I over segments. And finally, we're going to have a change in value. And this is again going to be lerping between 100 and perhaps 255, again by I over segments. And this will ensure that the base of our grass is a bit darker than the top of it. It looks a lot nicer that way. So now that we have our hue and value, we can actually create the color so that we can use it throughout. So we're going to call it base color, and it's going to be make_color HSV. So the hue is our base hue, Our saturation can be left at 245 perhaps, and our base value is going to be our value. Now we can do the same for the top. So we have our top hue, so first of all, top alpha, which is going to be lerping between the same values. That's important, you choose the same values as before. So 0.9, 0.4, and this time I+1 over segments, because we want it to match the segment on top. Next we have the top hue. We are lerping between, again, it's important to choose the same values as before, and I over segments. I+1 over segments. We then have our top value, which is going to be same values, but again, I+1 over segments. And finally, we can actually build the color. So our top color is going to be make color HSV. Our base, our top hue. Again, same saturation, 245, and our top value. So now we can actually go in and change our colors over here. So every time you see X1 and X2, every time it's like the first and second vertex, you want to use the base values. And every time you see the third and fourth vertex, you want to use the top value. So here we're going to have base color and base alpha, and very much the same here. So I'm just going to copy this here, paste it under this one and under this one here, and now we can have our top color and top alpha, and again just copy it and paste in the last two vertices over here. So now we can save this and run it, and we should be able to see a much nicer color gradient in our sprite, in our grass. So it's even a little bit red at the top, so you may want to dial down our top value here. You may want to, if I go up to this 40, you may want to make 50 or something like that. I'm just going to leave it as is for now. I think it looks pretty good. So now we can actually start tackling the animation. So the way we're going to do this is using a shader, and our shader will basically only be just a vertex shader where we're going to nudge our vertices a bit to the left and to the right to give it this nice waving motion. So we are going to first of all need to actually modify our vertex information and our vertex format a little, because what we want to have is the top of our grass bending more than the bottom of our grass, or a better way to put it is we're nudging the top of our grass more than the bottom of our grass to give it this bending effect. And for that to work, we need to be able to tell how much each vertex should be affected. So to do this, we're going to be adding a simple line of code. Let's see. We want to add a new vertex format, and we're going to use a custom type. And what we're going to be using is a vertex type float1. So this is a single floating point number, and what we're going to be using it is having it 0 when the vertices should not move. For instance, at the base of our grass, we do not want our vertices to move at all. And at the top, we'll have it at 1. 1 when you want it to move completely. At the top is where the grass will be most affected. Now here we have to tell it what the usage is. Now normally we would be using vertex underscore usage, and we would probably use blend weights, as that's really what we're using it for. We're using it as a weight. However, there's some binding errors in GameMaker and it doesn't quite work. So what we're going to have to be using instead is a texture coordinate. Even though we're not using it as a texture coordinate, we're telling GameMaker that we are, and it will trick it into working correctly. So this is it for the Vertex format, so we can save this, but now we actually need to do something with our Vertex information, and that is to add our different effects or weights. So what we're going to have is two new variables called var base weight, and this will simply be I over segments, and then we have our top weight, and this will be I plus 1 over segments. You should be able to see a pattern here. So again, this means that at the bottom of our graph we're going to have 0 as the weight, and at the top of our graph we're going to have 1, which will mean it will bend more, it will move more at the top, giving it this nice swaying effect. So now all we have to do is add this vertex information to each of our vertices. So we're just going to insert vertex underscore what is it, float 1, again because we're using a single number. We're adding it to our vertex buffer, and this is our base, so we're adding base weight. Again, we can copy this line and paste it underneath this vertex here. We want to add it under this one as well. And now we can add the top weights, so we just rename this here top, copy this line, and add it underneath our colors. Remember, we need to keep the order consistent. It has to be position, color, and weight. If you change the order, it will probably give you an error. If not, it will give you some very strange results. So this is it for the Vertex Blade. We can now start working on a shader to get this working. So what we are going to do is create a new shader. And what we're going to be calling it is SHD grass, because it's going to be our grass shader. So as you can see, when you create a new shader, I used Alt-A by the way to create a shader quickly. You just press Alt-A. It will create two new code windows. This first one here is our vertex shader, and the second one is our fragment shader. Now we're actually going to change our fragment shader to not even have a texture. So we can remove this last bit of code here and simply have our color. Now we don't have a texture coordinate either because we don't have a texture, so you can remove that line, and we can now leave this one alone. We can in fact close it down. We aren't going to be touching it anymore. So now that we're back inside our vertex shader, again we're not using a texture coordinate, so we can remove this line. This line as well can go, and this line down here. In our format, we said that each vertices had a weight, and so what we're going to be doing here is get that inside our shader. So it is a simple floating point value, and we're going to call it in weight, like so. Now we can actually start modifying the data a little. So what we can do is have a new set of coordinates, which I'm going to call transpos, which is our transformed position. And this is simply going to be our in position dot x in actually what you can do is simply do in position dot xyz and 1.0, like so. And down here, under here, you want to remove this. In fact, you can even remove this whole line here. Go down here where it says object space pose and put trans position. So in case you're not familiar with how shaders work, what this line here over here does is set the position, the output position of our vertices to be equal to a matrix times our transformed position. So by this matrix essentially transforms it from our world position to our screen. And for now, that's all you really need to know about this. So this is what this line over here does. All we really care about is what this transform position is. We're only going to be working inside world space for this tutorial. So what we can do as a proof of concept here is take our transform position and the x component of it. We can add our in weight, and let's multiply this by some value like 64 dot. I add a dot at the end of my numbers to make sure it is a floating point value and not an integer. That way I can multiply them correctly. So by adding this line here, we're not animating it just yet, we're just making it move by our weight factor, showing that the top of our blade will bend more than the bottom. So if I press run, we should be able to see not much right now because we're not using the shader, we simply created it. In fact, we have to go into a drawer event right here and add shader set, our shader, and remember to reset your shader afterwards. But if you do run it now, we should be able to see the top of our grass bending and not the bottom. So as you can see, we have a slanted effect right here. Now it doesn't really look great because it looks like our grass is completely rigid, it doesn't look like it's bending. So what we want to do is change from this linear system, and instead we're going to be using the smooth step function. So we can remove this and say smooth step, and here we want 0 point here, 1 dot here, and our in weight. So smooth step is a bit like lerp, but it draws a curve that starts off slowly, goes fast in the middle, and is slow again at the end. So now we simply multiply by, again, a large value like 64, press run, and you should be able to see the effects. Now, as you can see, it starts off pretty slow, then slants more and more, and then it stops slanting, it slows down, and that's just because of the curve the smooth step function draws. So what we can do to stop this is essentially what we want to do is only use the bottom half of our smooth step function. So we can just multiply our weight by 0.5 down here. That way we only use the bottom half of our curve. Now it also means that we'll only be moving half the amount, but as you can see, we now get that really nice curve effect, which really looks like grass blowing in the wind. So now we can start animating it, and that's where it gets quite interesting. So what we want to do is we want to be able to tell the shader what the time is, so it's able to animate it correctly, because shaders don't remember information like normal code does. So we need to give it extra information, and you do that with uniforms. So we're going to have a simple uniform called u_time, and that is going to be the time that we're currently at. And what we can do is multiply here that by sine of time. So essentially, by multiplying by sine of time, we're going to go from +1 to -1 and so on, and slowly over time, following a nice sine graph. So that's going to give it a nice swaying motion. In fact, it's not quite perfect because you do want a bit of erraticness, but you can change that by accelerating or decelerating time on the GameMaker GML side of things. So we can save this and go back to our create event. What we want to do at the bottom of our create event here is get that uniform, get the reference to that uniform so we're able to use it later on. So we can say uTime is equal to shader get uniform. Our shader is SHD grass, and the name of our uniform is u_time. It's important that you spell this exactly the same as you do in here. Otherwise, it won't work. Now we can have a simple variable called time, which will be the current time we're at. So inside the drawer event now, we can first of all update our time. So we can go in up by, I don't know, 0.7, 0.75 or something like that. Should be good. And then inside the shader set here, we want to change our uniform value. And that's, again, pretty simple. We just call shader set uniform. We want uniform F because we're using a single floating point value. The uniform was U time, and the value we want to set it to is time. So now if we save and run this, we should be able to see our grass sway from left to right. Unless we make a mistake in our code, which we did. So what's important to see is that here I simply use the variable time when actually I called it uTime. I'm using the uniform uTime right here. So now if I run it, it should work just fine. Here you go, we now have grass waving from left to right. However, it doesn't look quite right because grass doesn't go all the way to the left and all the way to the right. It tends to be more in one direction because wind doesn't tend to go from left to right like this. So a simple fix for this would be to grab our sine graph over here. And in fact what we can do is move it over to a new variable. So what we're going to do is call a new variable called float, of type float. A float, if you don't know, by the way, it's a floating point value. It's not an integer. It's a value with decimal points at the end. So what we want is a float. We're going to call it wind, and we can just grab our sine value here, place it back here, and here we can simply multiply by wind. This will make things a little bit easier. We can actually take this 64 out and move it back up here as well. Remember to make sure all your numbers are decimal points for it to work correctly. So as I was saying, you can get your sine graph to always lean towards one side rather than the other by adding 1 to it and then dividing by 2. Remember to use decimal points everywhere. So now if we save and run, we should be able to see our grass swaying more to the right and not to the left really, and it just looks a lot more natural. Now it still isn't quite right, everything is moving at the same speed and everything, it's not quite there yet. What we can do is make things go at different speeds based on their position. And one way we can do this is by adding to our time variable here, to our time uniform, we can add our position. We can add the x position, so that the more to the right you are, the more ahead of time you are. And what this, it changes the syncing of our grass blades, giving us a much more natural looking animation. Now here I just use impositional x and it will probably be wrong. Though actually it seems to work okay. Maybe the effect is a bit too strong, so we can go ahead and tone it down by dividing this by a value. So we can divide by 64 for instance. And now we see that it should be at a different sync than before. You can even turn this even higher up, so maybe we can divide by 512. Maybe that's too high though. So here's it's 512. It's slightly, you can see that it's slightly out of sync now. Now these values will really depend on your scene. It will depend on a lot of things really. And right now we're baking them into the shader with hard values. However, it's much better to pass them in as uniforms. That way different patches of grass can have slightly different values. But this is really essentially it for this tutorial. You now have some nice waving grass. You can change the speed of it by going inside the draw event and perhaps toning this down. Perhaps you only want 0.5. And what's great is that if you go to your room, you can actually add as many of these as you like. So you can drag in some grass patches and you can make it taller and add some here which is going to be very short, like so. And it's really quite flexible. If you wait for it to run, you'll now see that not only is it going to go slower because of the change in value, but as you can see, you can have some nice tall grass over here and some much shorter grass next to it simply by changing our sprite because of that initial step we had of checking the sprite width and sprite height. So you can still go further with this. You can add some more interesting animations by tweaking the function that we used. Instead of sine, you could use a mixture of sine and cosine and so on, to make some really nice looking grass. You can even add effectors so that as a players walk over the grass, it will push it out of the way, and you can do that again by passing in a uniform with the position of your player in there and checking if it's close to the position of the grass and moving it out of the way. And you can there's really a lot you can do with these shaders and uniforms. So I hope you have enjoyed this video and that you find it useful. If you have any questions or anything to add, please leave a comment down below, and I'll see you guys next time for some more GameMaker tutorials.